Hey everybody, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we're looking at Unit 6, Lessons 14 and 15, Equivalent Representations. So basically what we're doing in this lesson is seeing if we can determine whether two different representations of a linear function are equivalent. And so if we jump into this first example, it says that a repair person charges an hourly rate and a fee just to arrive. So we have a table that lists some hours worked along with the cost of the bill. We want to determine if the function representing the data in this table is equivalent to this function y equals 45x plus 65, where y represents the cost of the bill, x is the number of hours worked. So if we look at the table, we're given some different hours worked and then bills that match up to that number of hours worked. And so what we want to do is to see if this equation matches that. So if I plug in 1.25 for x, so remember this is my hours worked is x, the dollar amount is the y. So if I take 1.25 and I multiply it by the 45, so 45x, 1.25 times 45 is $56.25. Add that to the $65, and I do get 121.25. So that looks good. When x is 3, 45 times 3 would be 135. 135 plus 65 does equal 200. And then the last one, 5.25. So I multiply that by the $45 per hour, and I get $236.25. Add the $65 flat fee, and I do get $301.25. So in this case, we would say that the table and the equation are equivalent. If I plug in those values, those x values for hours worked into this equation, I do get the y value that is listed there in the table. All right, second one here says, write the equivalent of this function in slope-intercept form. So this is what we call standard form. Have the x plus the y equals a constant. If we want to write it in slope-intercept form is solved for y. So that means that I need to get this y term by itself. So I'm going to start by subtracting that 1.2x from each side. Those zero out here, and it leaves me with just 3.6y. And that's equal to negative 1.2x plus 6.84. Then my last step, to get that y by itself, I need to divide everything by 3.6. And I need to make sure I divide every term by that 3.6. And so I'm going to write this up here. Y is going to equal, well, negative 1.2 divided by 3.6. That's going to simplify down to negative 1/3 x. And then if I take the 6.84 and divide it by 3.6, I get 1.9. And so that would be an equivalent equation just in slope-intercept form. So that's what we're talking about, different forms of the same information, the same function that we're dealing with. All right, our last problem here says we have a manufacturing plant that can make two different products, product A and product B. Each product uses the same resources, which are replenished daily, and they always use all of the resources so that there's a linear relationship between the number of product A they can make in a day, which we're calling X, and the number of product B, which they can make in a day, which we're calling Y. And then we have the table here below that shows examples of how many they made each on a different day or on different days. So this is, let's say this is day 1, this is day 2. So we want to write a linear equation for the number of product B they can make in a day in terms of the number of product A that they can make in a day. All right, and so we can think of these in this table as ordered pairs. So when X was 2, Y was 12. When X was 6, Y was 9. And so we want to write an equation. Well, we have 2 points, so we can start by finding the slope. So my slope is going to be the difference between the Y values, so 12 minus 9, over the difference between the X values, 2 minus 6. 12 minus 9 is 3. 2 minus 6 is negative 4. So my slope is negative 3/4. Now I can use point slope form, and I'm just going to pick that first point. So y minus the y value, which is 12, equals negative 3/4 times x minus the x value there, which is 2. So that's what the equation would look like in point slope form. If we want to get it into slope intercept form, I would need to distribute that negative 3/4. So negative 3/4 times x, and then negative 3/4 times negative 2. That would be a positive 6/4. And 6/4 simplifies to 3/2. And then my last step here would be to add 12 to each side. So y would equal negative 3/4 x. I'm adding 12, which is the same as 24/2. So this would be 27/2. 24/2 plus 3/2 is 27/2. So this would be an acceptable equation in point slope form. This would be our equation in slope intercept form. All right, and remember, those are equivalent expressions. All right, and that's all I've got for you today. Appreciate you taking the time to watch. As always, if you do have questions, just let us know. Thanks, have a great day.